the first round is between you. So there might be that some of you had very urgent points to be clarified. I had one for you already. I told you the question we got from several people was, what really is going on in December in Geneva? Is it just have a nice dinner, nice discussion, Christmas shopping, or what is the content of the solution? And who is the main supporter of the change of the Vienna indirect law from the year 1968? So it's your turn.
Well, it will not be in Geneva, it will be in New Delhi. So if there is an agreement on the consensus, then it could be the New Delhi consensus. The recommendation is sponsored, as I mentioned, by a number of countries, and their paper is on the website, so if you want to read it carefully, you can download it. But in a sense, it addresses the different items in the Vienna Conventions that the vehicle has to have a driver. Now, this is not given up. A vehicle has to have a driver. But the different automation solutions should be sort of safely addressed. And because of that, there is a recommendation to peg it to the vehicle regulations. So as long as the vehicle is in compliance with the vehicle regulations from 1958 agreement or 1998 agreement, then there is no consistency problem with the Vienna Convention. If they are not in compliance with one of these agreements, then there must be a surety that that appliance can be switched off. So again, the driver would be in control of what's happening in the vehicle. But there will be a discussion. So these countries, as I mentioned to you, Germany included, Sweden included, and France included, and many others, by the way. This is to facilitate a discussion. So there will be a discussion, and let's see how the different participants react. You may feel free to participate in this discussion. Normally it's an intergovernmental discussion, but our working party meetings are totally open to businesses as well. If it comes to voting, it's only the head of the delegation of the governments are allowed to vote, but other than that, it's a totally open meeting. So if you wish, you can register for that.
Professor Flemisch, is that better now? That's much better. Thank you. Okay. Who Ms. Molnar, who is the power? Is that the Commission? Is it the working party, or is it yourself?
Well, the UN doesn't have a power. The UN is a facilitator. The governments have the power. Now, among the governments, some governments are more interested, of course, in finding a solution than others. But I would like to underline that the real problem is not the legal inconsistency. Of course, there are legal inconsistencies because the Vienna Convention has certain technical features, and the technical features are not to be updated in the Vienna Convention, but within the vehicle regulations. So that consistency issue will have to be handled. But the real problem is policy. And with these changes, you are opening up this legal concern, but you don't solve the liability, the insurer's problems. And for that, it's not the convention that needs to be modified, but you have to understand the policy implications, and then who is responsible, who is liable, how the insurers will react. Okay, and can we please repeat the homepage we can look to? What should we? It's easy, unec.org, transport website. Okay, good. So everybody who is now, even maybe in the afternoon session, will sit on the computer and will... I can give you a business card, so it can... Okay, marvelous. There was also a more general question, was whether we would be in any case able to solve this liability business in the United States. That was a question to you. I think every automotive company and also other companies were involved either in single
cases, and we will not immediately go to accident zero. We will have fatalities and we have injuries. And would with the American system it in any way possible to differentiate between then it's a vehicle manufacturer, it's an infrastructure person, and it's some outside, or it's NHTSA with this legislation, and we all were in the meantime involved in very often directly in this jury-driven liability cases where we have the feeling that is a discussion between the lawyers and we are just actors in some liability acts. Do we have any hope?
Yes. Somehow cars manage to be sold in the U.S. And only rarely do the manufacturers go bankrupt. So there is a business model. When we talk about solving the liability problem, I think we have to understand what that means. People get injured and then they sue. Not always, but we're dealing with real people who have real injuries who are looking for compensation. Now, in some cases, perhaps the party that ultimately pays, perhaps an automaker, is not the primarily responsible party. Perhaps it's not the most appropriate party, but it is a mechanism for injured individuals to get some compensation. Now, if there is a better means of delivering that compensation, and many countries have developed what I think are far superior means through personal insurance, through no-fault models, through a better social safety net, then by all means, that's a systematic approach. But simply saying that some individuals will have to suffer more for the gain of society, I don't think is a compelling social argument. And so companies are in the position in the U.S. of, in some ways, acting as insurers for risk. Not the ideal position for a company, but one that if you understand and can price the risks, you as a company can address through pricing and through insurance. So the real obstacle when we're talking about automation isn't the fact that there's a lot of lawsuits or that it may be inefficient. It's that actors just don't know what to do. They don't know what to expect at this point, as a technical matter, as a legal matter, or as a reputational matter. So providing greater certainty through, on the private side, further research and development, on the cooperative industry government side, standards development, on the government side, these policy questions about what kind of risks are acceptable and which are not, I think that will be essential to providing the greater certainty that will ultimately help solve the barriers that liability present to roll out of these technologies.
Anyhow, would not be an easy job, I think, for both sides. Okay, any question between you directly? Professor Flemisch?
I have a question for Ricky Hudi. First of all, it was very impressive to see how far enhanced the game is already. So 5 years ago, we had some projections that the earliest time this technology will hit the road is something like 25 or 30. And now it really looks that some part of the technology will be on the roads in a couple of years already. And you made this comparison with the pilot. Obviously, it's the driver still has an important role. His role might even be enriched as a pilot. I'm curious how people perceive this term piloted driving, whether they can make the right associations with that. Because usually non-flyers or non-pilots have difficulties in finding out the right role or knowing what the pilot does.
Yeah, you covered several aspects. The first part was more how mature is the technical realization close to an start of production, and the other thing is the anticipation how the customers deserve for that. I go to the first one. As I pointed out in my presentations, The progress in the high powerful semiconductors which we are using or we can use for the computing power is one important step. The other is that the cameras and the image recognition algorithms made very big progresses in the last years. Additionally, contributed to the semiconductor within the cameras. So several aspects come together that now is the time to reduce all the components necessary to that automotive shape and form, and also reliability, where it is state of the art and even higher in the complete automotive industry. And the second part, all the investigations and all the tests, and we did already a lot of tests with the Park Pilot and with the traffic jam pilot, are very convincing. The people who tested it, they were absolutely enthusiastic about that. You give up your car in a park house. By the way, last Friday we had another world premiere in Ingolstadt. We had opened a new park house, and together with the Oberbürgermeister of Ingolstadt, we showed this presentation how the car goes into the park house, and he were also very impressed, and he said he can imagine and that in future we have park houses where one part is piloted and the other part is free. So summarizing, the feedbacks we get for these two features are very convincing.
Now then we have a question from Detlef Frank to Dr. Lee. Where does your trust on an automated car come from? If I compare my personal traffic accident record, which I think is 0, to the number of breakdowns of my PC, I have my doubts.
It's a good question for me, because I'm the completely wrong person to put it to.
A medical person. Don't say that. I think any pacemaker in which is sold shows a very good reliability. When I talk to the people who have a pacemaker, they said, by the way, I just have to change the battery and nothing else. So medical people are using already computers.
No, I think it's easy to trust engineers when you're not an engineer yourself.
Okay.
It's easier. But being a bit more serious, I think there are solutions to the technical problems, again, which is reducing the potential energy. I've been presenting the ideas about a safe shutdown sequence for many years. That you can actually, if you get uncertain, if your onboard computer is saying I'm having trouble, you can in a controlled way get down in speed to safe levels. And I had a car of a German brand, which all by a sudden on the motorway only did 50 kilometers an hour. That was a shutdown sequence of that car because of an ESC sensor failing. And that was considered good enough for me to limp to the workshop and to get an ESC sensor. And I think we will see a lot of that with poor quality or low quality of the technology, that you get down to safe levels. And then you limp home to your workshop, you arrange it, and you fix it. I don't think that will be the key problem. I think it's more about the acceptability for other people around the car to understand why is this car all by a sudden so slow in the middle of traffic.
I would like to comment on that. I think that's an excellent picture, that the system then degrades and goes to a safe level. And this has been worked out in a very structured way in aviation. Airbus causes graceful degradation. And I think this is also the way to go with our automated systems. The driver has a really important role there, because drivers are, well, they might cause more than 80% of the accidents, but also most of the day they keep traffic safe. And in Germany there's a statistics that on average, the average driver needs 1.4 million kilometers before he causes a major accident where somebody is hurt or killed even. And that's quite an astounding amount of kilometers. And if we have discussed this in the coffee break, from a technological standpoint, the hurdle is quite high to drive automated 1.4 million kilometers in all circumstances. On the other hand, we might have a good chance to start in very safe environments like the interstate or like very good rural roads and drive automated there. And when the system degrades, we hand back to the driver in a very controlled way. So the symbiosis between the driver and the automation might make Vision Zero much more likely than without the automation.
Okay, I have given one card to Professor Bogenberger directly because I was not able to read the handwriting completely. So please read the question.
I have the same problem in reading a little bit the question, but it seems that someone is interested in the variable speed limit, and he thinks that it might have to do with the variances in speed and distributions, I think, and the rest is really hard to read. Of course, a variable speed limit reduces the fluctuations in speed overall, and it's a more homogeneous traffic flow if you look at the speed distributions compared to a freeway that doesn't have a system in operation. And I was really happy to hear from the Swedish Road Authority that they are highly interested in automated driving. It was a drastic statement of mine to emphasize a little bit the problem, but I'm really wondering a little bit, because we are talking about the safety problems more or less, and what a fantastic job Detlef and all others of us do in driving without almost any accident. But if I'm looking at efficiency, I think we are even better. So if we solve the safety problem, there's still the efficiency problem. And I would not be wondering if we would have fully automated vehicle systems, but we have longer jams. Because we do such a fantastic job in anticipating and in getting the maximum out of the system, if it comes to that. And one question that is not raised at all is, within cities we have emissions or emission problems, and what happens to that if we are driving fully automated? Is that getting better or worse? You might have the answer for that.
I don't have a real answer, but maybe a guess. Regarding the fuel efficiency, there are two sides of the balance to this. If we would implement the street regulations or legal regulations directly into the automation, this traffic flow would be much more inefficient than the human, because the human nowadays adapts. Sometimes the human violates laws for the sake of traffic flow, and also the authorities tolerate some of this violation, which is good. So in this respect, automated driving would not improve the efficiency. On the other hand, we have a couple of degrees of freedom where we can really improve something. For example, platooning. With automated driving, we can couple several cars. They can have a smaller distance. This has some side effects regarding the safety also, or the subjective impression of the driver, but this can be compensated. The big plus is that the fuel efficiency can be increased here. The numbers go from 10 to 15%. driving by a platoon. The really big plus that we get from automation, it will be safety, it will also be some efficiency, but the main plus we get is lifetime. That nowadays we are really wasting a lot of time driving in traffic jams and driving in situations where we would like to drive. Of course, it's nice to drive this R8 on a nice mountain road, but most of the times we're driving around in crowded interstates. And this is really a good situations where the automation can do the driving and we can use the time in a different way.
Okay, if I would like first to give the microphone to Ms. Molnar.
Well, maybe we agree too much, so I will have a couple of questions to provoke you. One, compatibility and interoperability of vehicles. Today, it's no problem to drive from one country to the other because actually the vehicles are not so different. As soon as we have different levels of automation in vehicles, would it lead to fortress countries, countries that are more developed and they don't receive other vehicles? It could be a problem for individual cars, but also trucks. So that's number one. Number two, again, Vienna Conventions, based on that, you have an international driver's license from your country, if your country is a contracting party. Now, do we need a very special training for drivers for highly automated vehicles? And in that case, would it be proper to accept the driver license of a person coming from a country that has not introduced automated vehicles and training for that at all? So are we introducing more discrimination into the international arena? And my third question is about safety. Yes, we cannot compromise on lives, safety. But I used to work in the World Bank, so for us, first you do the financial feasibility, then you do the economic feasibility, then you do the social and environmental feasibility. So the first question is there cost and money and time saved before you consider that the project can go ahead or not? And then you also look at the social impacts, particularly safety. When we speak about changing the functions, are we giving up on the time and cost? Would that mean that Europe, which is already becoming less competitive in the world markets, is becoming even less competitive, but we will save more lives? And the very last question, traffic rules. Could you imagine automated vehicles in countries where basic traffic rules are not in place?
That's a number of questions. That could be a presentation by itself, but it's not easy to answer. I try to give a little bit my thoughts, then let over to whoever would like to answer it. I think if we move on the approach to introduce driver assistance systems in a step-by-step function where under given circumstances, we heard about traffic jam because there is construction on the road or others, so that functions can be taken over by the car itself. I think until that we are always on the safe side, regardless which country we are driving. The real problem starts when we say, or if we are in a parking house or wherever, because we have an environment which the car itself with the driver knows. I think for me at least, unsolved period is after the year 2030, when hopefully then I'm dead. So I'm not in conflict with that. Is sitting on the rear seat or on the passenger seat and nobody is behind the driver's seat. I don't see that in a more general driving if we don't have a special area. So who would like to answer the very important questions, but I think we will have solutions.
Can I throw out additional questions related to yours rather than trying to answer? I mean, I will say that when we talk about what you do in an analysis, that on a macabre level, lives and costs and benefits are interchangeable, in the sense of you can consider lives saved as an economic benefit that improves competitiveness rather than merely a secondary benefit or as something that you get in exchange for giving up competitiveness. In the U.S., administrative agencies use a figure ranging from about $5 million to $10 million per life saved, in a variety of contexts. Conversely, when we talk about systems that make a vehicle more expensive, you can also convert that into less availability of the technology and therefore ultimately lives lost. It's a difficult and very value-laden calculation, but one that I think is necessary to consider. When we talk about the variety of different systems coming out in intermediate levels of automation, I think you make excellent points about country-specific compatibility. Something that concerns me for similar reasons is the inevitable obsolescence of technologies that seem really amazing when they first come out. So in the U.S., the average age of our fleet is just shy of 11 years. Imagine introducing an intermediate driver assistance system, or 20 different kinds, and then still having them on the road 10, 15 years later when they've traded hands 2, 3, 4 times. What will people expect of those systems? How will they interact with the vehicles on the road? How do we get them off of the road when we realize that they're as outdated as they've become?
So there were several questions to Mr. Hudi, which I think he might answer in one, because some were very similar, and maybe you also could comment on this question of what I'm doing, and I recall very good once a presentation of BMW in the United States in a test fleet with mini electrical vehicles, and how the cars looked like after they had been driven by private owner after 1 year. We were shocked. We said it can't be, but it was. So it's your turn.
Before I go to the compendium of questions here, I want to answer to the questions and comments of Eva. I think the most important step in introducing piloted driving cars is not to want too much with the first step. Do one step. For us, it's a traffic jam pilot, and convince with the results. And I give you an example of an existing system today where I use very, very often. It's the adaptive cruise control with a forward collision warning. At least 10 times it prevented me for a severe accident. At least 10 times. When I was not so with my thoughts on the road as I should be, and it prevented me. And I'm absolutely sure that the first step, the traffic jam pilot, will contribute to your visions and will contribute to much better safety. So now to the compendium. The first question, do we need intrinsically safer computation hardware? The mass market is there, but the products are dominated by the entertainment sector, and the architectures are event triggered. It should go to time triggered. Good question. The architecture we have on the driver assistance issue is a time triggered architecture. So we have an absolutely deterministic approach, and the computing power we are using we're doing this with a big player in the semiconductor industry, and we had already ways found how we come with selection of the semiconductor to automotive quality. This is the first. The second one is which requirements has the IT infrastructure to fulfill in case of bandwidth, the level of safety, and a worldwide, or here's a European-wide, I call it worldwide standard. We are on the way to equip all the cars with a communication module as a standard, and this standard is LTE. And all our tests we said were in that way satisfying that the bandwidth is okay to download additional map information. My strong request goes to the telecommunication provider, of course, and also to the government, that we get a 100% coverage for the online communication. That is a strong request.
Which is more difficult in countries like Sweden.
But maybe when we do a rewriting of the Vienna Convention, we can do one paragraph where this is forced. Just as an
But we learn. We
as
are
an
invited,
idea.
or we can trigger our government representative
Yeah.
who goes to New Delhi.
The next is
Find out.
current development tools for ADAS driver systems are limited when it comes to quick implementation of data fusion algorithms. How do you overcome this challenge to make algorithms as easy exchangeable in your central fusion? It's a little bit complicated, but I take a long story short. The modular architecture and the approach in this ECU, together with the time-triggered architecture, we did in that way that every functional block we can cut free in the system, debug it and develop it also offline and online. This is the short answer for this complicated thing. Maybe the person who asked this question can discuss this with me in the lunch break. It would be a little too far to cover it completely. The last one is you talked about sensor data fusion. How does a system decide if two or more sensors give completely different information and fusion is not meanful? This is also a separate worth for a separate lesson. That's the intelligence in the system design, in the failure tree analysis, in the ASIL level development, how level of ASIL A, B, C, D you put to which functionality, that you always have reliable and safe operation.
But I think, Mr. Hudi, that is an area I think we have to work on. If you look to the different warning levels today in the car, the most unuseful is the wiper and water container for the wiping system. If it's empty, it gets you crazy. That water refill, water refill, water refill, and so I think once we are going forward with more piloting, we have to look also to the incoming telephone calls, incoming mails, incoming SMS, and whatever. Too hot engine temperature is more dangerous than others. So I think that's something the vehicle manufacturer really have to work on, not to get that the driver gets crazy. For me, if I'm on the Autobahn and I know the next gasoline station is 40 kilometers far away and I get this damn washer system, refill washing, well, I think
Before Mr. Flemisch answers, one comment from my side. It's always our top priority to reduce the driver distraction, and for that reason, central information concepts where a mail function is indicated are an appropriate solution for that. And believe me, the investment in all these things to reduce the driver distraction as to a minimum, even if the functionality is high, is on the highest level of attention. But now to you.
Well, my comment goes into a similar direction. We have a real challenge here that we integrate more and more functionality in the car, and we also link our car to the internet, so more and more information presses to the driver, presses into the car, and we are, you mentioned these messages. The cars get more and more intelligent, so more and more messages will pop up. And there was a development in the nuclear power plants in the 80s and 90s. They faced a similar challenge, and they then worked out nice intelligent systems that prioritize these messages and also understand the context and then give only the messages that are the most important in the specific situation. So this is also crucial to transfer this kind of know-how into the automation domain. I would like to come briefly back to your mass of questions that are really crucial, especially the question of standardization and compatibility. We already have quite a problem nowadays with today's cars. If we look at the way how we activate an adaptive cruise control system or an LCAS, they are all different in all cars. So when you drive only one car, you learn it once and this is fine for the rest of your driving time. But when you are changing between cars, let's say rental cars, this can be a real nightmare. And we are trying to solve this nightmare in the ISO and standardization bodies, but this is difficult because all the car manufacturers want to differentiate themselves from each other with the interface. They want to have a special interface, and I don't want to go into detail about differences of Audi and Mercedes and BMW, but this can be really difficult then when it comes to highly automated functions, because when you can't operate it, then errors happen and real accidents can happen. We have discussed this in one of the EU projects, HAVIT, once again, where the starting point was also very different between the manufacturers, Volvo and Volkswagen, and supplier Conti. And we solved it in a way that we have worked out a backbone of behavior and rules of the interface so a kind of standardization between all the different partners. And then the skinning was left to the car manufacturers. So the surface looked different and looked brand for the specific brand, but the underlying rules were the same and the logic were the same, so that the drivers could transition between all the different cars. But this is not trivial. It's probably years and years of negotiation and testing.
But I think I'm not so much concerned about that. The generation which is now growing up is much more better trained on computer and computer handling than we and most of us. And if I look to my grandchild's, what my 10-year-old granddaughter can handle, I'm not so concerned. We will learn it, and we must learn it.
Trial and error works great for video games, works less well for cars on highways.
Yeah, but you see, even today we have different MMI solutions, and normally if you get even on a car rent in a new car, you are able to learn it immediately. So I'm not. I personally am not so concerned. You had a question?
No, I wanted to answer a question. Yeah. Question number 4 of Eva. And question number 4 was the traffic behavior in different countries, and if it's technically possible to come up with an automated system. I had the great pleasure to work with Sadi Lofte, who was the inventor of fuzzy logic on my PhD. And we were working on ramp metering and on the merging process, and had many discussions about automated driving. And he was a fantastic engineer, and I always cite him when it comes up to this question. And he said, on a freeway, no problem. In Los Angeles, no problem. In Munich, no problem. Istanbul, difficult. Tehran and New Delhi, impossible. At least when we are looking at the traffic behavior they have right now. And a second question you raised, I wanted to emphasize, because you were talking about the harmonization process, the international harmonization. And if I look at roads and traffic management systems, it's more or less an example where it doesn't really work, because we have different tolling systems in all the different countries, and in a way that's a much easier task to harmonize a tolling system. And in Germany we are now we are having a fantastic automatic truck tolling system, and instead of using this tolling system and increasing it for regular vehicles, we are talking about a very simple system now with stickers on the license plate. And this demonstrates for me that even on a national level it's difficult, but on an international level harmonization is really, really difficult.
But the people who have worked like myself more than 40 years in harmonization of legislation, no chance. We for example, when we tried, it took maybe 20 years before we were able to harmonize the test dummies for crash testing between the United States and Europe, which indicates that all Americans are different from us. Must be. Otherwise, we couldn't have different dimension on a 50% male or 5% female. Because the companies and the organization were so strong behind their production tools or their legislation. When I was a young engineer, I tried together with the French government to introduce American emission cycle to Europe. Monsieur Calvé from Peugeot was close to kill me. So I have not very much hopes there, but that's the reason why I'm saying I trust more in the vehicle. The vehicle must take over most of the job we are talking. Otherwise, we have no chance in the countries where we have the high amount of fatalities. And if you look to the statistic in the United States, we had 40,000 people fatalities per year. We had that back in the 1970s, and we have it today. I agree with more cars on the road, more driving miles, but the absolute number, we were not able to reduce dramatically, and I think we cannot, as society, live with high amount of fatalities. I have one question to both of you. The sequence of answering is up to you. So, will autonomous car require an introduction of black boxes like in the airplanes? That means accident recorder to save the later product liability cases or accident reconstruction.
Well, actually, black boxes already exist in road transportation more and more. As you know, one of the insurance schemes, the green card system, is based on one of the UN legal instruments. And we have a meeting with the Council of Bureau of the Green Card Insurers every year. And I hear that the use of black boxes is going up very fast. So it's already a reality. So most likely it will be happening more and more. I would also like to qualify a little bit this safety issue, that I don't want you to believe that we in the UN believe that safety could be optional. It's not optional, it's a must. At the same time, I would like to underline that economic efficiency is not optional either. It's a must. It's a must. If you look at the future of the world, we speak about reduced poverty that needs not only better distribution that is needed, but it needs economic growth. And everybody, all the scholars say that economic growth will be driven by trade growth. And for trade growth, you need mobility. You need freight mobility, but tourism was one of the drivers behind some improvement over the past years. So you need tourism as well. So the economic efficiency cannot be neglected either. So that would be the point here. And I would also like to come back a little bit to the traffic rules, because it was a loaded question, of course. If you look at the global figures about improvement in road safety, and I don't speak about Sweden, which is really setting a wonderful example, and some other European countries have been setting very nice example. But if you look at the global figures over the past couple of years, not this and last year, because we don't have that figure yet, but before that, what you see that road safety has not improved globally. Mm-hmm. It's a bad message, but that's a fact. So it hasn't improved globally. And most likely it will not be improving if we continue to grow mobility with the same speed as in the past. And where we have the highest road safety problems, these are the countries which actually have not joined the Vienna Convention. So if you wish, I say the basic traffic rules are laid down in the Vienna Conventions. And if you don't have basic traffic rules, you don't improve road safety. And even for automated vehicles, we saw that beautiful picture by Anders that the car is physically stopped behind the bus. Yeah. But, you know, there is a traffic rule, for example, in the US, you would be fined if you take over a school bus. You are not allowed to take over a school bus. Yeah. That's a traffic rule. So sometimes you don't need to have physical obstacles. You just have to have rules, and they have to be implemented. Mm-hmm. You may want to speak about that.
Yeah,
the question was also to you.
So I agree with everything you said. And you know, I think when we look at the development of automobiles, the tremendous personal human cost that went into the development, experimentation took place in society. We learned that, we have to make this axle stronger because the last one broke. You know, 100 years ago, 10% of automobiles would just catch on fire in a year. You'd walk on, they'd be on fire. And then, you know, that's not the kind of innovation we need today, but there's a cost to that innovation, and that's very important. We're kind of in the realm of made-up numbers when we start talking about these things. The number that traffic fatalities and injuries costs $300 billion in the U.S. every year. Mm-hmm. That's, you know, completely made up. The number that congestion in the U.S. costs $100 billion, so significantly less in fatalities, also made up. But you can start comparing these made up numbers and look at the extent to which congestion balances against injury. You know, if you look at the time spent in a car, that's 11% of U.S. GDP in a year. Again, made up, but instructive nonetheless. So when we're talking about data, you're absolutely right that recorders are increasing in cars. The U.S. federal government has gone and is going through some rulemaking on a very strange black box rule of its own. Black boxes are a very, very small part of what will be the overall data collection in any of these vehicles. I say that at least the data potential is the equivalent of taking a dozen smartphones, turning on all the sensors and cameras, linking them to your social media accounts, and then strapping them to the inside and the outside of your car. And that's an understatement of at least the potential. Now, whether that will be used, transmitted, shared is a question for companies and for regulators. It's worth pointing out that some of the research vehicles have little privacy warnings on them that say, well, warning, you are being recorded or videotaped. The role of data in litigation and discovery will be huge. Already today, the first call that any good attorney should make in a lawsuit involving a crash is to the cell phone company to find out what the driver was doing when they crashed, if they were on the phone or texting, because they probably were. Imagine a future where not just the vehicles involved in the crash get subpoenas for records, but all of the traffic cameras that were recording the crash, all of the other automated vehicles that just happen to be passing by and may have recorded or transmitted certain data that would be relevant. It's a huge amount of information, and I don't think the legal system has any idea yet how it will really have to deal with information of this magnitude.
I think the first technical solution where we indirectly were using a crash recorder was in the beginning of the airbag time. We wanted to know whether the accident was severe enough, or if we had a failure with the sensing of the explosion device of the airbag, which is now standard. And I think just think about the huge capacity Mr. Hudi will install in his car, and easily he can have some last minutes. You have a trajectory, you have steering angle, you have a lot of other information, braking and everything, and I think that it will in the future, that will be a combination.
There's a utopic vision of being able to press play and play back the crash and explain away everything. There's some potential, but that will never be completely possible in a broad sense or resolve some of the underlying design defect issues that will drive many of these cases. There's a great example of an automaker actually arguing that its own data were incorrect and winning on that basis. I think you had a comment.
Yes.
There was one question also to you, maybe you can't answer that. That was, you talked in your speech about certified lanes, that they are necessary. Do you have ideas how such a lane, because it relies also to your question, where there is no road compared to our views like in the States and like in Sweden or Germany, what should such an automated lane has to have? What should it include?
Yes, we had intense discussions here in the EU, and was a very quick consensus reached that the situation in the States can't just be copied. We don't have the luxury here to just implement a couple of new lanes and then reserve them for automated traffic. So the default should be that we should be able to work with the existing lanes, and that we should be able to have mixed traffic on these lanes. And regarding the certification, it's important to establish a kind of slim control system that the lane stays as it is unless it's changed, and if it's changed, for example, by a construction site, that this is then integrated into a database. The database has to be maintained, and the cars who drive along, they have to be aware then of this change. There's an equivalent, once again, in the aviation domain, where every change in airports, you might be aware that many accidents have been happened, especially in the 70s, in airports, really severe accidents, 747s crashing into each other due to some changes in the infrastructure. And they have then established severe system of notification, NOTAMs, which is still maintained, and now it's computerized also. And we might need something like this NOTAM system also for our roads. Of course, this involves also the authorities who maintain the roads. I'm not so pessimistic that they might also be able to do this. It also involves a slim car-to-infrastructure communication. The nice thing is that this communication doesn't have to be really hardened in a way that it's always reliable. Because when the communication is down, then we simply don't allow automated driving. But when we want to drive in a what we call a secured lane, so where the driver really goes out of the loop, then it has to be made sure that this lane that the car uses is really safe, and there's no other car blocked on this.
But we need for this type of sorts the political and social power. And for example, we have today, as I learned from the newspaper, not enough money to repair our roads. So then we can naturally look to Sweden. If you drive from Malmö to Kalmar, which is in south in Sweden, they had years ago was a road with a heavy accidents, fatal accidents. What did the Swedish people do? They changed the total road, that in both directions you have possibilities. With a sign in 10 kilometers you can come to a place where you can take over. So you are patiently behind a truck, because you know in 10 kilometers you get the chance to pass them, and that goes in both directions. The reduction is close of fatal accidents on that road is close to zero. So not only with the support in the cars, I think we can come closer to our vision zero. We have also to look to the traffic infrastructure and a lot of other things. It must be a total system approach, and it must be social accepted. And what I'm a little bit ashamed of is that safety, for example, is not discussed in Germany in the public. It's not an item. So also we have natural improvements, but we still have 3,700 people, bicycle driver, kids and elderly people and pedestrians and cars and trucks, and everybody is too much. And if you look to the severe injured, this number is not discussed at all, because they has not reduced dramatically. We were successful in reducing the fatalities, but we were not so successful in reducing the injured people. Last words before we go to lunch?
Oh, no, I just wanted to say it's very important what we are touching upon here when you talk about automated transport, not talking about the autonomous vehicles, that it really is pushing development of infrastructure. You know, the last innovations in roads were roundabouts and motorways 50 to 100 years ago. It's a product which has not developed a lot. And we see huge potential in actually finding low-cost, efficient solutions dedicated for automated cars. You can build bridges and flyovers where you know the cars are never closer than 50 meters. You can make them very narrow. You can be very innovative also in the room of the road. And that's something I think we should explore a lot more between infrastructure and vehicle manufacturers. What are the combined potential effects where we can be innovative, not looking at the autonomous car only using the system as it is today. There is a system of tomorrow that we can develop together.
It was a good word for concluding our small discussion on the morning session. I would like to thank all speakers for the preparation, for the talk, for your thoughts, and I think we are astonished how far we already are in the vehicle. And thank you to the audience, also to the people who did the discussion, and I expect an active engagement in the afternoon working group, and then we solve all your questions. Have a good lunch. Thank you very much.
Thank you.